Okay, so moving on from perfect squares, what if we have non-perfect squares? Such as, like the square root of 12 and 2 times the square root of 3. Well, let's see if we can examine part A, where it asks us to confirm that both are equal to each other by squaring both. So, the square root of 12 squared, much like how when we have a squared term on the inside of the square root, it cancels each other out. Even if the square is on the outside, like we have now, it does the same thing. They cancel each other out. They're inverses of each other. So, the square root of 12 squared is just 12. Another way we could look at this is by saying, all right, the square root of 12 squared is the square root of 12 times the square root of 12. And the way this square root multiplication works is you can just combine them into a single square root, where you have 12 times 12. And this will be helpful for what we're going to do later. And we should hopefully realize that that is, of course, 12 squared, which is just 12. So again, that is how, well, two different ways we could imagine part A. The second way might be a little bit more helpful to us for the next couple parts. Oh, wait, we're not even done part A, sorry. We also want to square 2 square root of 3. So we're going to square that, and that is going to be 2 square root of 3 times 2 square root of 3. And we can rearrange this a little bit so that the whole numbers are together. So we have 2 times 2 times the square root of 3 times the square root of 3. Now, what that becomes, 2 times 2 we know is 4, and the square root of 3 times the square root of 3, much like how we did square root of 12 times square root of 12 here, and it became 12 times 12, we're going to get the same thing. It becomes 3 times 3, which becomes 4 times the square root of 3 squared. They cancel out the square root in a square, and we get 4 times 3, which is 12. So what we have just established is that 12 is equal to the, 2 square root of 3 squared. We've established that. That's what we just did. And we also have established that the square root of 12 squared is also that same value. So, in conclusion, and I'm going to write this in red, we have that the square root of 12 is equivalent to 2 times the square root of 3. Okay. So, moving on from here, let's do part B. So I'm going to move down a bit. Part B states, what was it? Simplify the square root of 18. Now, part A is supposed to help us develop some sort of intuition on how we can manipulate these square roots in order to simplify them. Kind of like doing the reverse process of what we did with 2 times the square root of 3. So what I'm going to do is say, well, I know 18. 18 is... Well, I know it's 2 times 9, so I can rewrite it like this: 2 times 9. And I also know, and you should hopefully see a 9 being as a perfect square. So maybe you don't need to do this extra step, but I'm going to do it anyway. We have that 9 is the same thing as 3 squared. So we have 2 times 3 squared. Now I'm going to, instead of like when we multiplied square root of 3 times square root over 3 here, and we put it inside the same square root, what I'm going to take over here is I'm going to separate their square roots. So we have the square root of 2 times the square root of 3 squared. That becomes square root of 2 times, and the square root of 3 squared is just 3. And more simply written, we always put the whole number first. The square root of 3 times 2. So what we have just established is that the square root of 18 is equal to 3 times the square root of 2. Okay, continuing on from there, part C asks us for the square root of 432. So part C, the square root of 432. Alright, so a bit of more complicated value. If you are clever or good with factoring, you might see that this is divisible with 3, because if you add the digits together, 4 and 3 is 7 plus 2 is 9. If you add those digits together and it's divisible with 3, then that number itself is divisible with 3. And you could realize that if we split it up as 3 times 144, we could easily get the square root of 3 times square root of 144, which we know at this point is 12. So our answer would be 12 times the square root of 3. Now, but let's say you didn't know that right away. Let's say you didn't know to divide by 3. So what would you do? Or factor it into 3? Well, maybe for instance you say, well, I tried, it's an even number, so I could divide by 2, or I could divide by 4, maybe that'll work. In this case, I see that 4 is divisible with 4 and 32 is divisible with 4. So what I can do is divide this up as 4 times 108. And then, well, I can split that up as the square root of 4 times the square root of 108. And then abbreviate that, the square root of 4 is 2 times the square root of 108. But hopefully you notice that this 108 is an even number, which means we could simplify that down even further. So I'm going to keep the 2 the same. Now 108, I should see that 10 is 108 is also going to be divisible by an even number. And I know personally I like to try out like 4 if it's an even number first, because it'll help break things down faster than if I split it up into 2. But let's do, if we divide by 4, it would be 4 times 27 to get us 108. And then I break that down even further. 2 times the square root of 2. No, sorry. Square root of 4 times the square root of 27. And again, the square root of 4 simplifies to 2. We have our square root of 27. And we have 2 times 2, which is 4. And then we have a leftover square root of 27. But hopefully we see 27 can be broken down as well. So 27 is the same thing as 9 times 3. Or, yeah, well, whatever. We'll write it like that. So this can be broken down even further as 4 times the square root of 9 times the square root of 3. And the square root of 9 is 3. I have the leftover square root of 3. And then finally, 4 times 3 is 12. Leftover square root of 3. And 3 cannot be broken down anymore. It's a prime number. Its only factors are 3 and 1. So we cannot break it down any further. So we have simplified it as much as possible and have discovered that the square root of 432 is equal to 12 times the square root of 3. Finally, for part D, simplify 1176. So, square root of 1176. Alright, well, that's a bit challenging. Okay. Well, I'm just going to note that it's an even number. And like I said, I like dividing by 4. Even though it's an even number, we know it's divisible with 2. But if I divide it by 4, it's going to help break it down faster. And you will get that you can evenly divide it with 4. You get 4 times 294. That gets you 1176. Then we can split the 4 off. Times 294. And the square root of 4 is 2. With our leftover square root of 294. Now we see that that is an even number. So we can split 294 down even further. So we have 2 times the square root of. Now, if we divide by 4, it ends up not being divisible with 4. So, we know it's an even number. So we can make it divisible with 2. So if we do that, we get 2 times 147. Sometimes even I need a calculator. And well, notice, well, that we don't have anything we could simplify from there. But 147 might have some factors. So let's think about that. We can split this as 2 times the square root of 2 times the square root of 147. Now we can't break this down any further yet. But let's see what we can work with the 147. I don't know if we know this trick or not. But again, if you add up all the values in this number, and if that number is divisible by 3, the number itself is divisible with 3. So 1 plus 4 is 5, plus 7 is 12, and 12 is divisible with 3. So 147 is going to be divisible with 3. And if you didn't know that, just try dividing by simple numbers like 3 or 4 or whatever until you find a nice even factorization. So we have 2 times the square root of 2 times... Now we have 3 times... what is it? 49? I think. Let's do it real quick. All right. 127 divided by 3. Oh, wait, 147. Sorry. Yeah, it's 49. So, interesting. Hopefully the 49 pops out at us, and we can see that that is a perfect square. Now, if not, you could break down the 49 and stuff, but what I'm going to do now is say that 2 times square root of 2 times the square root of 3 times the square root of 49. Now, the square root of 49 is the same thing as the square root of 7 squared. So it's going to simplify to just a 7. The square root of 49 is 7. So we have 2 times the square root of 2 times the square root of 3 times 7. Then from there, what I'm going to do is group together my whole numbers together. So 2 times 7 are going to go together. And then I'm going to have my square roots together. 2 times square root of 2 times square root of 3. 2 times 7 is 14. And like we've shown previously, we can combine these together. So it's the square root of 2 times 3, which means that it simplifies to 14 square root of 6. So establishing the fact that the square root of 1176 is equivalent to 14 times the square root of 6, giving us our answer.